What is up, people? It's me, Teja, and in this video we're going to talk about SQL injection. Now we're going to cover a lot of things in this video. We're going to first talk about what exactly is SQL and what is SQL injection. I'm also going to practically demonstrate SQL injection by doing it on a vulnerable application. But hey, the application that I'm using in this video is actually vulnerable by intention, and it is actually generated so that security researchers or pen testers can improve their skills by testing the application for flaws and different kinds of vulnerabilities. And this application also happened to have SQL injection vulnerabilities, and I'll be showing how to exploit SQL injection vulnerabilities. Please be noted that this video is only for educational purpose. Trying to exploit bugs or vulnerabilities like SQL injection vulnerabilities or even other vulnerabilities on websites that you do not have permission to is illegal, and you will get into serious troubles for doing so. So when you're practicing SQL injection, make sure you do that on your own website or websites that are intentionally made vulnerable so that you could test your skills and practice your pen testing skills. So I'll be showing two such applications in this video, and also show you how to get those applications on your system so that you can test on those applications and exploit different types of bugs. But in this video, we'll be talking about only SQL injection. Before getting started, I also want to thank the sponsors of this video, Snyk. Now, I don't know how I end up getting such great sponsors every time, and I'm glad to say that Snyk is one of my most favorite tools that I've ever used in my whole career. I don't know if I could call it as a career, but in my experience, I would say. So what Snyk does is it basically finds out vulnerabilities in your code. It can automatically find out vulnerabilities in open source softwares or libraries that you use in your code, and it will show you the metadata or the details of the libraries which are vulnerable, and you could fix these vulnerabilities with Snyk. And the best part is Snyk is free to use. You could use Snyk for free on your projects. Even if it is a private project in a private repository, you can still use Snyk to test your code and keep your code vulnerable free. So I want to share my personal experience with Snyk. So I have this personal project of mine called Secure Text, and it's basically a web application using which you can store your notes or texts securely and then encrypt them with a password and then access them whenever you like from wherever you are. So a month back, I used Snyk to scan my project. The project is uploaded to GitHub, so I used Snyk to scan my GitHub repository. You can do that directly from the web interface of Snyk, and Snyk immediately scanned my project and it came up with some vulnerabilities that existed in my application, and I did not even know that these vulnerabilities actually existed. So I'll show you an example of that. So you could see there are 3 pull requests opened by Snyk. I'll show you one of that. So this one. So it says Snyk has created this PR to fix one or more vulnerable packages in the pip dependencies of this project. So as you could see, there are 2 vulnerabilities that Snyk found out when I first scanned with it. And the first one is called web cache poisoning. And you also have a link to that vulnerability so that you could learn more about what is it, which package has this vulnerability, and how to fix this. So Snyk automatically told me that there is this vulnerability which has a medium severity, and there's another vulnerability which Snyk found out, which this is called the directory traversal vulnerability. And if I go to this link, it shows me all about this vulnerability, and this also appears to be in the Django framework. So essentially, any attacker could use this directory traversal vulnerability to read files on my web server that are not supposed to be read by any visitor. But this vulnerability allows anyone to traverse through the directories on my web server and read sensitive files in the file system. And I am so thankful to Snyk right now because it helped me fix some serious issues on my project, and I did not have any idea about it until Snyk notified me. So yeah, it's just such a great tool, and it's also free to use. So I don't see why you should not try it. So do check out Snyk and try it. It's a must-have tool for anyone who writes code. And you can use my link in the description to try Snyk for the first time. It's free to use. It's a great tool, and trust me, you will not regret using it. So go ahead and check it out. So without further ado, let's get started. So before talking about SQL injection, you must obviously know what SQL is, which you probably already do, but for the sake of like going step by step, let's talk about what SQL is. Now, SQL stands for Structured Query Language, and it is a pretty popular language to deal with databases. To be more precise, to deal with data inside the databases. So basically, using SQL, you can deal with the data that is stored inside the database management system. Like you can create a new database, create a new tables, add data to those tables, and modify the data which is already existing in that tables. Like for example, changing the value of a particular row or a particular column, deleting a particular row or a table, and so on. Basically, you get the idea that we use SQL to deal with data inside a database management system. Now, SQL injection is a technique where an attacker can craft a malicious SQL query or an SQL statement, and the attacker tries to inject this specially crafted SQL statement into the pre-written SQL statement on the backend of that web application. Now what happens is this specially crafted SQL statement of the hacker or the attacker gets executed along with the pre-written or the hard-coded SQL statement on the backend of the web application. So this means that the attacker can execute SQL queries on the backend of the website, which means he could basically do anything with that particular database. Like he could read the values from a table, or even update the values in the table, create a new table, or even worse, he could just delete the whole database. Now, SQL injection is actually the top one OWASP security risk, which means it is pretty common to find these vulnerabilities on websites, and it also severely hurts your web application if your web application happens to be vulnerable to SQL injection attacks. So as I already promised, in this video I'm going to try to practically exploit SQL injection vulnerabilities on a vulnerable application. So let's go ahead and do that. So the application that I'll be testing is this one. It is called Juice Shop, and it is an intentionally vulnerable website. It has many vulnerabilities, not only SQL injection, it has all the other vulnerabilities, the top 10 OWASP vulnerabilities to be precise, and you could use this vulnerable application to test your pen testing skills and whatnot. So the easiest way to get this application working on your PC is to use Docker. So first, obviously, you need to have Docker installed. So you can go ahead and just Google Docker download or something like that. And you could download Docker for Windows, Mac, or Linux. And once you download it, you know how to install it. So once you have Docker installed, as you could see, I'm running Windows. So I have Docker for Windows installed. So once you have that, you could just open up your Windows terminal or your command prompt, and then just get this image, the Juice Shop image of Docker. So you can just copy this command and go to your terminal and just paste it. And that's going to pull that Juice Shop image to your Docker. All right, so there you go. I have successfully downloaded the Juice Shop image to my PC. Now all I can do is I can start an instance, or I can start a container of that image, and I can do that simply by using this command right here. So I'll just go ahead and put this command here as well. Just clear the terminal and put it. So what we're basically doing is we are running a container of that image, and we are also exposing the port 3000 to our local host, so that when you go to localhost followed by 3000, we will be able to access that web application that we are running. So let's hit enter. Okay, so it says that ports are not available. It means that some other application or process is using the 3000 port. So let me try to use another port right here. Okay, so I finally got it working. So I used a different port, 8001. Instead of 3000, and it worked. So I'm guessing 3000 is being occupied by some other process. Anyway, now it's running. So I'll just go to localhost 3000. What is that? 8001, right? So there you go. This is OWASP Juice Shop, the vulnerable application that we are going to test in this video. And the reason why I actually chose this application over other applications, I mean, there are plenty of other applications like BWAP, DVWA. I actually will use DVWA later in this video, but the reason I chose this application primarily is because it resembles a real-time application. It doesn't seem like an application that is only made for pen testing. Like, it looks like a real website, it looks like a real juice shop website. So there you go, there are different products on the home page. If you click on the products, it shows some description and whatnot. There's a login form and there's a registration form. You could create a new account and register and whatnot. So we're going to try to find out if there are any SQL injection vulnerabilities. So first we'll be looking into this login form. So you could just give some email and just the password, and it gives you an error message saying invalid email or password. So we will first check if this login form has any kind of like an SQL injection vulnerability, right? Now, whenever I am testing an application for any SQL injection bugs, what I would like to do is I would like to open up some text editor like Notepad and try to figure out the SQL query that might be hard-coded on the backend. So in this case, we are testing this login form, and think about what it does. So you as a user, you give in the email and the password, and then you click on login. And then what happens when you click on login is that these details are sent to the server, where the server gets these details that are sent by you. And now it has to validate if the email and password that you submitted are valid or not, right? So what it has to do is it has to retrieve the correct email and password from the database, and then it has to check the submitted email and password with the correct email and password and check if they match. And if they match, it means that the login is successful because the credentials are correct. And if they do not match, it means that you entered a wrong email or password, so it would not allow you to log in. So that's the functionality. That's the basic functionality of any login form, right? So since we are retrieving the email and password from the database, there is obviously the need for SQL. So there can be a potential SQL injection vulnerability here. So before getting started, before trying to find out the SQL injection vulnerability here, what I would like to do is I would like to frame as an SQL query that is responsible to make this login form work. So as I said, this login form, it involves retrieving the correct email and password from the database. So let's try to write an SQL query for that. So I'll say select, which is a statement used to get some data from a particular table. So select email comma password. Now, once again, these column names might not be the exact names of the actual columns on the database. These are just hypothetical. I'm just trying to write the SQL query that might be utilized on the backend. So select email comma password from users where email equal to, and then this should be the email that the user provided as an input. So let's say that the name of that is submitted email, and password equal to, and this value should be the password that is submitted by the user. And let me call that as submitted password. So this is the basic SQL query that I can come up with, which can perform the login operation, which is checking if the email and password are valid or not, basically. So this submitted email and this submitted password are the user inputs, which means we control these things. We have total control over these two values because we are the ones who are sending it by using these fields. So that means we could send whatever we like. We could replace this to whatever we like. So what I can do is I can give it a malicious input and see if I can change this hard-coded SQL query in some way and see if it works. So what I'll do is for the email field, for the email input, I will give a single quote, and I'm giving this single quote to close this opening single quote. So basically what this does is this value I'm giving it as a single quote, as you could see. And what this does is it closes this opening single quote. So now we have 3 single quotes, and that should give you an error, right? Because a string should start with a single quote and end with a single quote, but we have an extra single quote, and this just violates the syntax of SQL. So what I'll do is simply I'll put dash dash here, and dash dash is basically a comment in SQL. So what happens is this will get replaced by this input. So now what we are doing is we are saying where email equal to an empty string, because there's nothing inside this single quotes, which means it's an empty string, followed by dash dash. Anything after this dash dash will be a comment, which means it will not be executed. This portion of this SQL query will just be rejected. So let's try that user input here in our login form. And the password, it doesn't really matter. You could just give any string as a password, because as you could see, we are commenting out everything after this closing single quote. And this means that this password check is also being commented out. So if I click login, it still says invalid email or password. So that means we did something wrong, and let's try to figure out what did we do wrong here. Okay, so here is why it did not work. So what we're basically doing here is we're selecting email and password fields from the users table, where email is equal to an empty string, and then we are commenting out the rest of the SQL query. And the reason this did not work is because there might not be a row in the users table where the email is an empty value. So we will have to modify this statement, or our input to be precise, so that it will actually return something, right? So I'll just add an OR statement, and I'll say 1 equal to 1 followed by 2 dashes, and I'll remove this comment from here because we don't want this portion of the input to be commented out. So what happens now is I'll just copy this and paste this in our input. So what happens now is it's once again going to try to get an email and password fields from the users table, where email is an empty string, and then it's also going to say OR followed by 1 equal to 1, which we know for a fact is true. So this is going to return true, and then we're commenting out obviously the rest of the SQL query. So what this does is it basically retrieves the first row in the users table, and this means that this statement actually returns a row, which means the login should be successful, and we should be able to log in with the user whose record is the first row in that users table. So let's try that input value here. Just copy that, paste it, and as I said, the password doesn't matter, so I'll just give some string right here, and there you go. It seems like it logged in, which it did. As you could see, we logged in with admin@juicesh.op. Now the reason we logged in with this account is because this user's record is the first row in that user's table, and it worked. That's great. So now let's look at some of the other features or other functionalities in this website where there might be an SQL injection bug. So the first thing I notice is this search box here, the search operation. So if I search something, it's going to show me the results that match my search query or my search string. So if you think about it in a developer's perspective, if you think about it, how this would be implemented in the back end, here is how it goes. A user gives a string to search for, and then in the back end, this string must be searched in the database to see if there are any results that match this particular string. So obviously there is the need for SQL here. So there is also a potential SQL injection vulnerability here. So let's try to do that. But for this, I'll be using burp suite to intercept my request, and it basically makes it easier for me to modify my request to whatever I need, and it also makes it easier to repeat the same kind of requests and monitor the exact raw responses I receive from the web server at the same time. So I'm using burp suite for this. So now I can intercept this request with burp. So I'll just search for something like test, and I'll make sure that my intercept is on in burp, and when I hit enter, you could see that there's a get request that's being sent to API/quantities, but I don't think this is related to our search. So I'll just forward this, and there you go. Now we have another get request we are sending a get request to /rest/product/search q is equal to, and then followed by the search string. So this is the request that we are sending whenever we are searching something. So I'll send this to repeater. So q is the parameter that we want to check for SQLi vulnerabilities. So first what I'll do is I will just put a single quote as the input, and I'll send this request, and the response we got is a success. We got a JSON response which says status is equal to success, and we did not get any data. What if I just give a normal input and click send? So I searched for the string test and it gave a status success, and in the data it gave me the search result that matches the string test. So let's try with a single quote and then followed by a dash, I guess, like commenting out the rest of the thing. So if I click send, all right. So here we could see we got an error this time, and we got a message that says SQLite error incomplete input. Now this means that this search functionality of this website is actually vulnerable to the SQL injection, and the type of SQL injection we're dealing with here is called error-based SQL injection. The reason we call it error-based is because we were able to see the errors that occurred while processing the SQL query in the background, in the backend, I mean. And based on these errors, we could, it is basically easier for us to read these errors and improve our payloads or our inputs. In other words, here there is an SQL field that shows you the SQL query that is being executed in the backend. So this made it easier for us because now we don't have to frame this SQL query like how we did for the previous challenge. So you could see it says select start from products where name, and then they're using the like clause followed by, so this is our input. If you could notice, this is the input that we are giving. So it's basically enclosing this with two opening parentheses and then followed by a single quote, and inside the single quote there is our input. So now we know that we need to escape one opening single quote, and also we need to escape two opening parentheses, right? So this time we will give it a single quote followed by two closing parentheses and then followed by the comment, because we want to comment out this all the rest of the statement, which goes like or description like followed by something. So yep, so this should work, because you could see we are first escaping the opening single quote, and then we are escaping both the parentheses, and then we are commenting out the rest of the query. So if I click send, you could see here that the status is success, which means this time we did not encounter any error, which means our SQL injection worked. We were able to modify the hard-coded SQL query and it did not throw any error. So these are the results. So there are a lot of results, and the reason why there are a lot of results is, once again, we are searching for an empty string. We are not giving any string to search for. So it's basically going to return all the products in the database. So now that we know this is our payload that we'll be working with, we can improve this to do something more. So what if you want to like know the version of the database? Now we know that this database is an SQLite database, because in the previous error message that we have seen that it is an SQLite database. So what I'll do is I'll try to get the version of this SQLite database. And how do I do that? Well, let's ask Google about it. So I'll say how to get SQLite version. Okay, so this is a Stack Overflow page, and someone answered that you could just use select SQLite version to to get the version of the current SQLite running, right? So let's try to do that. Let's go back to Burp Suite, and here we want to insert this select statement before the comment, because we don't want that to be commented out. So I'll just paste that over here, and you could see with the color schema that something doesn't look right. So I'll just show you. If I click on send, you could see that the response we get is bad request. The reason why we are getting this is because we did not encode this input. So since we are dealing with a GET request, the input we are sending is sent through the URL. So when you're sending some stuff through the URL, you have to make sure that you encode it. You have to URL encode it. So let's first URL encode it. You could do it in Burp Suite. I think there's a shortcut in Burp Suite using which you could automatically encode it. I don't know, let me search for it. Keybind to URL encode burp. Okay, it says Control Shift U to URL decode. Okay, Control U to URL encode, I guess. So let's try that. I'll select that and say Control U, and there you go. Now you can see that this SQL query is encoded. So now we can send this. If I click send, all right, we got another error message, which means our query did not work. But let's read the error message, because as I said, that's an advantage we get with error-based SQL injection. We will get to read the error messages, and by reading that error messages, we could craft a better version of our SQL injection payload. Right, so okay, it says SQLite error select, near select. So let's go to the SQL statement that's being, SQL query that's being executed. So it seems like we did properly escape the single quote and the two parentheses, but then this is not allowed in SQL. If you want to have two select statements in a single SQL query, you have to use union. So union is basically like joining two queries into one. So in this case, we are actually trying to execute two queries. You could see the first query is this one, select star from products where name, like, and this one, right? And the second thing we are executing, the second query that we are executing is this one. So we can't just concatenate these two queries like that. We have to use a union in between, right? So that's the error. That's the issue we are facing. So here in my input, I'm going to now add a union statement in between both these selects. And Burp Suite actually, while you type it, Burp Suite automatically encodes this, the input or whatever. So now if I click send, that should work, right? So it seems like we got another error message. This is a different error message from the previous one, and it says selects to the left and right of union do not have the same number of result columns. Okay, so what this means is that both the selects, which are on the left side and the right side of the union statement, both of them, they should have the same number of columns. Only then the union statement will work. So how do we fix this error? In order to fix the error, we obviously need to know how many columns we are actually dealing with, because only then we will be able to bring in those number of required columns to the right select statement, which is select SQLite version. How do we know how many columns we are dealing with? This first select, which is returning all the columns from the products table, we don't know how many columns it is actually returning, because we don't know the schema of this table products. So we have to somehow figure out how many columns we are dealing with in the first select statement here. So how do we do that? We could actually make use of the order by clause to do that. So order by is when you want to order your results based on a particular column number. So what we can do is, first I'll just remove all this union select everything, because we want to make use of the order by clause to figure out the number of columns we're dealing with. So I'll say order by followed by 1. And what this means is whatever the result set we are getting as the output for this SQL query that is being executed in the back end, we want to order the results with respect to the first column, right? So if I send it, you could see that we did not get any error. The execution is successful, which means it works. So now what I'll do is I'll keep incrementing this number. This time I'll say order by 2. I'll send it again and you could see there is no error. It says success. So I'll just change this to 3 now, send it again, no error. I'll keep it to 5 this time, no error again, and then 7, no error again. I'll just keep it 8, no error again, 9, no error, and then 10. This time it gave us an error. It says first order by term out of range, which means the number that we gave to the order by class, which is 10, is out of bounds, which means there is no 10th column for this table, for the result set, I mean. So what we can make from this is that there are 9 columns in the products table. Why? Because this query did not give an error until order by 9. When we did order by 10, it gave an error. It's saying that it is out of range. So we just figured out how many columns there actually are in the products table. So now that we know that there are 9 columns, we can now frame an SQL query that also has 9 columns as the output. So I'll say union again, and I'll say select, and I'll say 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so what I'm trying to do here is the right select statement. You could see I'm selecting just the numbers 1. Okay, I missed 2 there. So yeah, I'm selecting just the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not doing anything. So if I click send here again, you could see there's success. So this means that the number of columns in the right select statement equals the number of columns in the left select statements. Great. So now coming back to our version number, how do we get the version number of the current SQLite database? So in one of these columns, I could, let's say for the first column, I could insert a nested SQL query, which means I could give an open close parenthesis, and inside this open close parenthesis, I can type another individual select statement. So I'll say, we know the statement, we know the query to select the version, right? So it's select SQLite underscore version. So this is the select statement we can use to get the version number of the SQLite database. So I am actually nesting it in the first column of the right select statement. It might be a little tricky, but if you do know how SQL works, or if you have any little experience with SQL, it shouldn't be confusing at all. It's pretty straightforward. But if you do not have any prior knowledge with SQL, it's very, very, very easy to learn. Trust me, it's very easy to learn. You could just learn the basics of it in like 1 hour and you'll be fine. You should be able to understand that. So yeah, anyway, now if I click send here, that's a good sign. We did not get any error, which means the query that we injected got executed. So if I scroll down to the search results, you could see the last search result right here. It has the ID as 3.34.0. That is the version of our SQLite database. Now, the reason why it got assigned to this ID field is because we are injecting this SQLite, select SQLite version query to the first column of the select, of the right select. So just to demonstrate it to you, if I just take this out and then put it, take this out and then put it in the second column. Make sure I follow the syntax correctly. If I send it now, so now you could see the version number got assigned to the second field, which is name, because we injected or we nested this SQL query in the second column, in the place of the second column. So this means we are not only able to retrieve details or data from the products table, but we're also able to retrieve data from other tables as well by using the union statement to combine multiple SQL queries together. And actually you could only combine multiple select queries and not any other queries like the update queries using union. So you should keep that in your mind. So yeah, there are many things you could do like this, but I don't have to manually craft these SQL queries by myself because there is a tool that can automate all of this. It's called SQL map and it's used by almost all the pen testers. It's an awesome tool. So let me go ahead and show you how you can actually use that tool to automate the SQL injection attack. So you can just search for SQL map, the first one, go to the first link. It's sqlmap.org. So it's written in Python actually. So you could just download the latest version of it. I have already downloaded it. Let me show you how I actually use it. All right. So in order to run this, as I said, it's written in Python. So in order to run this, you need to have Python installed. So say Python sqlmap.py. You also obviously have to give it some arguments so that it can process. But if you want to just know the help, if you want to see the help menu, you can just give -h for the help, and it's going to show you a help screen showing you different types of commands and arguments you can pass to it. Obviously, there are lots of ways you can make use of SQL, but this is how I like to use it because it's very easy to use this way. So what I do first is I capture my HTTP request using burp suite. So this is the request we are dealing with. So what I do is I intercept this request and then I copy all this request, and then I open Notepad and I paste this request into the Notepad. And there are a few things that you need to change before you go ahead. So in the first line, in the get path, you also need to include your domain name followed by your port. So in this case, I'm dealing with my local host on port. What's the port? I forgot the port. 8001. So I'll say HTTP localhost :8001. Parameter we're looking for is this Q parameter. I'll just tell SQL map right away that this is the parameter I want to target. And in order to do that, you just type in asterisk right here. So this asterisk tells that this is the parameter that is vulnerable to the SQL injection. And so SQL map will only test this parameter. And that's it. You now save this as a text file. So I'll just save it as request.txt. And now I can just give this request.txt file as an input to SQL map and ask it to test for SQL injection vulnerabilities and to do stuff. So in order to do that, I'll just say Python sqlmap.py tag r and then followed by the request.txt file that I just made. Okay. Oh, yeah. There you go. The request.txt file that I just made. And after this, you could also give it the number of threads you wanted. So obviously the more number of threads, the more faster it runs. So I'm just going to give it like 6 threads. So initially I want SQL map to find out all the databases available. So I'll just give the command --dbs, and I guess that's it. So if I hit enter, it should start its thing. So it returned with a message saying on SQLite, it is not possible to enumerate databases. So it says use only tables. So let's do that. So instead of DBS, I'll say tables and hit enter. So once it's done, you could see it lists out all the tables. There you go. There's addresses table, there's basket items, baskets. All right, so now let's go ahead and try to get all the data from the users table. I will do that by first actually specifying the name of the table by using the -d argument, and the name of the table here is users, and then I'll say --dump. So what this is going to do is this is going to dump all the data inside the table which we have mentioned, which in this case is the users table. So when I hit enter, it's going to go ahead and do that. All right, so we are done. It has done dumping all the data inside the table, and you could see it actually also saved that into a CSV file located at this directory. It also printed it to the terminal, but it doesn't look pretty. So we'll just open this file and see the table for ourselves. So there you go. It seems like we have a total of 20 rows in this table, and you could see all the columns and the corresponding data. Yeah, what we essentially did is we used a tool to automate this process of exploiting an SQL injection bug which we found. So we are done with the first type of SQL injection, which is error-based SQL injection. And as I already said, there is another type of SQL injection called as blind SQL injection. And it is actually much more complex than error-based SQL injection. It is more difficult to exploit blind SQL injection bugs as compared to error-based SQL injection bugs. The reason is simple. In error-based SQL injections, you were able to see the error produced on the backend, and you were able to read that error. You were able to frame or construct a malicious input based on that error you see, and that is easy. That's a simple process. But that's not the case when it comes to blind SQL injection. So in blind SQL injection, you do not get to see the error that is generated on the backend. And obviously, this takes a lot of patience, a lot of trial and error methods in order to successfully be able to exploit a blind SQL injection. But before going further, let's see if we can use Sneak to automatically figure out or find out these bugs. For example, these SQLi bugs, which we found out just now. So let's do that. So you can go to sneak.io and you will find everything you need to know about Sneak here. You can download Sneak CLI, or you could just create an account here, and then you could use Sneak from the web interface as well. But I do have like the Sneak CLI version. You could actually easily install it with Node. So just say npm install g sneak, and that's going to install Sneak. So there you go, Sneak is successfully installed. So now I'll just go to the directory where the source code of Juice Shop is present in my computer. So yeah, this is the directory where the source code, all the files of Juice Shop are present. So once I'm in this directory, all I can do is type in Sneak test. So Sneak is now going to go through these files, and it's going to gather all the dependencies or all the libraries, frameworks, etc. that are used in this project, and it's going to query its vulnerable database to check if any of the open source libraries or frameworks used in this project are vulnerable. So it's going to take a little bit of time to scan all these libraries, so we have to wait a little bit. All right, so there you go. It seems like Sneak has done its job. So let's go through the results it gave us on the terminal. So it says that it tested 937 dependencies for known issues, and it found 36 issues and 52 vulnerable paths. So let's try to go through this. So here are all the issues that it found. You could see that these are all the vulnerabilities that actually exist in this application. There are actually tons of vulnerabilities, but it makes sense, right? Because this application is supposed to be vulnerable. So yeah, these are all the vulnerabilities. So for example, there is this authorization bypass, which is high severity, and you also get a link to the vulnerable database, which contains the data about this particular vulnerability. So if I just copy this link and go to this link in my browser, I can see everything I need to know about this particular vulnerability. So in this case, the vulnerability is authorization bypass, and it is affecting Express JWT package with versions less than 6.0.0. And here is a little bit of overview about it. And here we also have a fix for this issue. The fix in this case is to upgrade Express JWT package to a version higher than 6.0.0. And similarly, we have lots of other vulnerabilities here. For example, there's this arbitrary code execution, which caught my eye because arbitrary code execution is always a very, very serious vulnerability. All right, so that's great. Like seriously, that's awesome. But what if you want to fix these vulnerabilities automatically? Should you like go to each of these vulnerabilities, read their description, see how to fix them, and then fix them manually? Should you actually do this manually? The answer is no. Sneak can do this automatically for you with just one simple command. And I'll show you that magical command right now. And it goes like this: Sneak wizard. That's it. Sneak wizard. That's the magical command you need to fix all of these open source library vulnerabilities at once automatically. You don't have to do anything. Just run Sneak wizard and hit enter. And Sneak is now going to fix all these dependency vulnerabilities for us. And for each vulnerable dependency, Sneak also shows you like multiple remediation options. So for example, for this vulnerability in path shows me these are all the remediation options. So choose the first one, which is like reinstalling that package with a higher version. triggers upgrade to path parse. So basically I am upgrading path parse 1.0.6 to 1.0.7. So I'll choose the first one, hit enter, and it's going to fix that. Now it comes to the next vulnerable dependency, and I once again have all these options, and I will choose the first option again. Yeah, I'll do the same for all the other things. Alright, it seems like Snyk is now done fixing all these vulnerable libraries by upgrading them to their latest versions. And I also want to add that you could even use the GitHub integration tool on the Snyk dashboard itself if you're not really very fond of the command line interface, which is understandable. So all you need to do is log in into your Snyk dashboard, and once you integrate your GitHub account with Snyk, you can simply add a project and select GitHub from the list of options, and this will list out all your GitHub repositories. Now you can simply choose the repository which you want to scan. In this case, I want to scan my forked juice shop repository, and you can simply scan it. And once the scan is done, it's going to show me all of the vulnerable dependencies. Now, this is exactly what you saw on the Snyk CLI as well, but this is just a new way of doing it. We are doing it directly on a GitHub repository. Now, once Snyk lists out all the found vulnerabilities, you could fix these vulnerabilities individually, or you can fix all of these vulnerabilities together. And what Snyk does is it basically opens a pull request, making necessary changes that are required to fix these vulnerabilities. And as you could see, Snyk has indeed made a pull request on my repository, and it also clearly explains what are all the changes it made in order to fix these certain vulnerabilities. Now, all I have to do is merge this pull request, and that's it. My repository is now vulnerability free. But the main topic of this video is SQL injection. So how can Snyk contribute to finding SQL injection bugs? So as I already told this about Snyk, Snyk can not only scan open source code, it can scan your own code, which is the code that is written by you. So in order to demonstrate this, I'll open the Juice Shop project in my Visual Studio Code, and I will install the Snyk extension in Visual Studio Code. So here you go. This is the Snyk vulnerability scanner plugin for Visual Studio Code. It is available for other IDEs as well, like Eclipse and other popular IDEs, but I'm using Visual Studio Code now, and I've already installed it. So once you've installed it, you could see this icon of Snyk, which is a dog. I love dogs. And so what I can do right now is I can click on Snyk, and as soon as I click on that icon, you can see that it is collecting all the files in the current directory, which is the Juice Shop directory. And it's going to scan all those files for us and show us any bad practices in the code. So it is going to take some time, not gonna lie. It's going to take like around 5 to 10 minutes. So I'll just pause the video until Snyk is done. So Snyk is done scanning all the files in my current project directory, and since this is my first scan, it's going to take a little longer. But if you're scanning a project that has already been scanned, then it's not going to take much time. So remember that first scans are always going to take longer, but all the other scans after the first scan are not going to take much time. So as you can see, once Snyk is done scanning all these files, it will show you the list of files which have issues in their code. So I can see there are like a lot of files which have issues, and it makes sense because this application is supposed to be vulnerable. So if you, for example, like open one of the file, it will show you a sublist which shows you all the issues that are available in it. So for example, if I go to, let's say, recycles.js, it shows that there are 2 issues available. So if I want to check out these issues, I can just click on them, and Snyk will show me the line at which this issue exists. And on the right side, it will also show you what is the particular issue, and it will show you more details about it. But I want to see if Snyk actually detected SQL injection bugs. So I will try to look for a login.js file. Here it is. You can see it already has 3 issues. If I extend it, these are all the 3 issues. The first issue says something about unsanitized input. That looks interesting, so let me check that out. So if I click on it, it shows you that on the 29th line, which is where the hard-coded SQL query is actually present, it says that there is an issue here. And on the right side, you can see the message it gives you. It says that there is a high severity for this issue, and it also says that unsanitized input from the HTTP request body is being utilized into the query, and it also says that this might even result in an SQL injection vulnerability. This means that Snyk actually automatically detected that there is going to be a potential SQL injection bug because of this line over here. You can also see that Snyk shows you how other developers fixed this kind of issue. You could see this issue was fixed by 91 projects. So here you could see this is how one of the developer fixed it. The red portion means that the line was removed and the green portion means that the line was added. So you can go through each of these examples provided by Snyk, and you can decide which one you want to use or which one you want to consider to fix that particular issue in your project. So that's about Snyk extension. This is how Snyk can find out bad practices in your own code, and it can also help you fix those bad practices. Since this video is getting long, I had to split it up into two parts. This will be the end of part 1. In part 2, we will be dealing with blind SQL injection, which is a little bit trickier when compared to error-based SQL injection. So make sure you watch the part 2 as well. Check out the description or the pinned comment of this video to get the link to the part 2 of the video. So this is it for part 1. I will see you in the part 2. And before switching to part 2, make sure you like this video if you did like it, and also leave a comment down in the comment section below. Please do also subscribe if you did not subscribe yet, and also turn on the bell icon to receive instant updates from my channel. So I'll see you in the part 2.